When light shines on a metal plate, electrons are found to be emitted from the plate. This is known as the photoelectric effect. At the turn of the 20th century, the nature of light was believed to be completely understood. Based on experimental observations such as the Young's double-slit experiment and the theoretical considerations of James Clerk Maxwell, light was believed to be an example of an electromagnetic wave. The results of one experiment at the time, however, were not able to be explained by the wave model of light. This experiment is the photoelectric effect, which ultimately led Albert Einstein to propose a particle model of light. Three key experimental observations associated with the photoelectric effect are: 1. The amount of time before electrons are emitted from the plate is negligibly small. Electrons are emitted almost instantaneously as the light hits the plate. This is difficult to understand from the wave model point of view. The wave model predicts a heating effect, with the amount of time predicted before electron emission being considerably more than what is actually observed. The second observation is that the number of electrons being emitted by the plate per second, the so-called photocurrent, is proportional to the intensity or brightness of the light. This is actually not in contradiction with the predictions of the wave model. A third experimental result is that the energy of the emitted electrons does not depend on the intensity of the light, but does depend on the frequency or color of the light. Low frequency light, like red light, causes low kinetic energy electrons to be emitted. Medium frequency light, like orange, produces medium Ke electrons. And high frequency light, violet light for example, causes high Ke emission. There was no mechanism within the wave model of light that explained this relationship between electron kinetic energy and light frequency. In fact, a more exact relationship between electron kinetic energy and light frequency was found to be true. The kinetic energy of the emitted electrons was found to equal a number, today called Planck's constant, times the frequency of the light, minus a quantity called the work function, whose value varies as you change from one kind of metal to another. This mathematical relationship between electron kinetic energy and light frequency was something the wave model could not explain. The contradictions between the predictions of the wave model of light and the experimental observations led Albert Einstein in 1905 to propose a particle model of light. Einstein's model of light is based on two assumptions or postulates. 1. A beam of light consists of small bundles of energy, today called photons. And 2. The energy of a photon is related to the frequency of the light by the simple formula E equals h times f, where h is Planck's constant. This simple particle model is able to explain the quick emission of electrons in terms of immediate one-on-one collisions between photons and electrons. It is also able to explain the higher kinetic energy of electrons emitted due to high-frequency light in terms of those photons transferring more energy to the electrons they collide with.